associated with a changing climate will continue to build up until the world reduces greenhouse gas emissions and counterbalances any remaining emissions with equivalent removal of greenhouse gases from the atmosphere. To do so, it will require decarbonizing industry, mobility, buildings, agriculture, and waste, and restoring a seventh forestry and other land use that acts as both a source of a natural sink of carbon dioxide and other greenhouse gases. So, in this slide, you can see that for the power, there is a white circle is given. The white circle represents the generation of carbon dioxide, and the gray represents methane. You know, the greenhouse gases can be generally categorized into three. One is carbon dioxide, which is the most dangerous one, methane and nitrous oxide. Methane and nitrous oxide, they are short-lived. They don't stay in the atmosphere for longer, so that is, they are not so harmful, but still they are greenhouse gases. So industry produces a mix. They also produce carbon dioxide and methane. Mobility here represents the logistics. Logistics means automobile and transportations. So that is also generating a lot of carbon dioxide. Then the buildings is a smaller portion of carbon dioxide. Whereas in the agriculture, we have majority the methane generation. But the carbon dioxide is very, very minimal. Carbon dioxide, whereas the tractors are used or the small portion is there. And then the forestry. Forestry, the general question will be, why forestry? Forestry is the plants, and plants usually absorb carbon dioxide. So why are we giving? But if you see, the deforestation of the earth is going on in a continuous manner. So when you do the deforestation, so the capacity to absorb that carbon dioxide diminishes. So the carbon which is entrenched in the earth's surface, that gets liberated, and that combines with the earth's atmosphere or the oxygen to generate a carbon dioxide. Hence, deforestation amounts to generation of carbon dioxide. That is why that big white circle under the forestry. And then the waste, as we know, the organic waste, they all generate methane. Next. As of December 2022, more than 70 countries accounting more than 80% of global carbon dioxide emissions and about 90% of global GDP had put net zero commitments in place. IICHE had more than 5,000 companies, maybe more now, as part of the United Nations Race to Zero campaign. Decarbonizing the energy and land use systems will be possible only if 9 systems level requirements are met, encompassing physical building blocks, economic and societal adjustment and governance, institute and commitment. The average combined global land and sea surface temperature of this past decade was about 1.1 degrees Celsius warmer than the pre-industrial temperatures. And what is that pre-industrial temperatures? How do you of the world decided that this will be the pre-industrial area. We are losing roughly about 3,000 cubic kilometer per decade. In 10 years' time, 3,000 cubic kilometers of ice is melted. Climate science tells us that main driver of this temperature increase is the human-caused rise in atmospheric levels of carbon dioxide and other greenhouse gases like methane and nitrous oxide. To stabilize the climate and limit physical climate risk, climate science tells us that it is necessary to reduce the addition of greenhouse gases to the atmosphere to net zero. So how it will happen? So the projection has been taken from 2020 or 22 to 2050. So you can see now in the world, around 40 billion tons of carbon dioxide is producing and damaging the ozone atmosphere. So the sun ray is directly able to come into the earth, and our earth's temperature is going up. Now, there are various segments of carbon dioxide production: the power, industry, buildings, agriculture, forestry, land use. So the power is little darker in blue. Then we have to see that we have to reduce the high emission sources of power, coming down to low emission power. So similarly, in 2050, you can see the resultant carbon dioxide, which is given in the black dotted line, is coming to the zero level. But we are also doing some, like in your mobility, you cannot reduce, because mobility is transportation, which is the logistics which is required. So what to do it? You can reduce by doing carbon sequestration. So by doing that, you take out that carbon dioxide from the atmosphere. So your ultimate aim is to reduce that to zero in 2050. That has been decided in the countries of a conference of parties, that is COP28. Of course, this is the 28th summit which was held in Dubai. As a result of this relationship between cumulative emissions and global temperatures, Earth has a so-called carbon budget, a specific amount of carbon dioxide that can be emitted before it becomes probable that warming will exceed a certain level. Intergovernmental Panel on Climate Change report estimated that restricting the net emissions 400 to 500 gigatons of carbon dioxide, combined with substantial decreases in emission of short-lived GHGs or greenhouse gases like methane, would result in a 50 to 60% probability of limiting warming to 1.5 degrees above pre-industrial levels. But if we can restrict it to 1150 to 1350 gigatons of carbon dioxide, then the warming may go up to 2 degrees Celsius. The vast majority of carbon dioxide emissions, next. The vast majority of carbon dioxide emissions, as much as 83%, is energy related. You can see here in this slide, energy use accounts for almost 83% of carbon dioxide emitted across energy and land use systems. And when it is energy, so energy is produced by coal, energy is produced by natural gas, energy is produced by oil. When it is oil, we are talking about furnace oil or diesel oil or low sulfur oil, LSHS. So for the coal, it is the highest. 35% of carbon dioxide is generated from the energy produced by coal. Similar, 17% by the natural gas, and 31% in the oil. And the division has been given in different industry. Like for coal, it is the power industry is the highest, the darkest area, and industry is the next. Similarly, for natural gas, it is also divided between power, then industry, and buildings. So like this chart shows, but the last one on the right side is non-energy system. So non-energy is the forestry division. So forestry, it is shows, so you can, from here you can see what is the amount of deforestation is going on in the world. That is why so much of carbon dioxide is generated. So we have to restrict the deforestation by planting trees so that it brings in absorption of carbon dioxide. The vast majority of carbon dioxide emissions, as much as 83%, is energy related. Combustion of coal makes up to 35%, oil additional 31%, and gas is 17%. Actions to reach net zero emissions include shifting the energy mix away from the fossil fuels and towards zero emissions electricity and other low emissions energy carriers such as hydrogen, adaptive, industrial, and agricultural process, increasing energy efficiency and managing demand for energy, utilizing the circular economy, consuming fewer emissions like intensive goods, deploying carbon capture, utilizing and storage technology, and enhancing sinks of both long-lived and short-lived greenhouse gases. Next. So this is another example how these carbon dioxide emissions are concentrated in the power and industry sections. You can see this, 30% of carbon dioxide is generated from the power, then industry is another 30%, mobility is 19%, buildings are 6%, agriculture is 1%, and forestry is 14%. And when it is, if we do the subdivision of all this, so electricity generation in power segment is 97% is coming, generating carbon dioxide. Similarly, in the industries, it is divided into steel, 26%, cement, 20%, oil and gas extraction, 15%, chemicals, 12%, coal mining, 6%, and others, 20%. Mobility, the road, which is the transportation, the vehicular transportation, 75% of carbon dioxide generation is through that. Then the aviation is 13%, maritime, the shipping industry, which is giving 11%, rail is 1%, and others are less than 1%. Buildings, mostly residential, it is 70%, and the commercials are giving 30%. Similarly, for methane, you can see also that industry is giving 33%, and agriculture is giving 38% generation. Forestry is 5%, and waste is 23%. And nitrous oxide, mostly it is agriculture. Next. So this is, we discussed about this in the first slide, that $275 trillion the world has to spend for next 30 years. So this slide shows the division of various industry, how much amount will be spent by each and every industry. Like you can see that hydrogen and biofuels and heat, agriculture, industry, forestry, fossil fuels, buildings, power, and mobility. Each segments, they have to spend huge lot of money so that we can achieve that net zero transition or the zero carbon dioxide emission to the atmosphere. Next. So when you go to 2050 in 30 years, we are spending a huge lot of money to change from high emission energy to low emission energy. So while doing that, you are acquiring new assets. And the old assets which we already have, those have to be junked. So in this transition process, what is going to happen? There will be a lot of new employment will be generated. And in the process, with the old assets are getting junked, so people associated with that also will get fired. So the net resultant, this study is done by McKinsey, one of the best consultants firm in the world. So they have shown that around 202 million jobs will be added. 25 will be added, 9 will be gone. Hydrogen, since it's new, nobody is engaged in hydrogen, so 0 will be gone, but 5 will be added. Similarly, in oil and gas and coal, there will be 33 will be gone, and there will be no new thing because coal will be totally banned from this world after some years. Similarly, capex jobs also 40 will be added, however 35 will be gone. I'll just read it out on the power generation, what is happening. So generating electricity and heat through burning coal and natural gas, to a lesser extent oil, accounts for 30% of global carbon dioxide emissions, of which China and USA alone, they produce nearly half. Achieving zero emissions electricity requires accelerating the replacement of fossil fuels in power generation with low emission sources such as wind, hydro, solar, and nuclear. The growth of renewables like solar and wind raises the questions of how to deal with their daily and seasonal intermittency and ensure reliability. Various options are considered for this. Improvement of storage technologies, use of carbon capture, and power to gas to power conversions, or some areas where lots of research work is in progress. Industry. Industry accounts for about 30% of global carbon dioxide emissions, 33% of methane emissions, and 8% of nitrous oxide from various industrial processes such as production of steel, cement, chemicals, and extraction of refining of oil, gas, and coal. Emissions results from burning of fossil fuels for energy from the production process itself and from fugitive emissions from extractions, refining, and transportation of fossil fuels. Decarbonizing industry emissions would require a shift to processes and plants that are more energy efficient, using alternate fuels and inputs such as green hydrogen and scaling carbon capture, utilization and storage of hard to abate emissions, and to name a few decarbonization actions. Mobility. Road, aviation, rail, maritime, and other forms of transportation contribute approximately 19% of global carbon dioxide emissions annually, with United States of America producing nearly 1/4 of that total and 2% of nitrogen oxide emissions. The primary decarbonization lever is replacing internal combustion engine vehicles with battery electric vehicles and vehicles powered by hydrogen fuel cells, supported by expansion of corresponding infrastructure, electric charging stations, and hydrogen fueling stations, plus upstream production and low emission electricity and hydrogen. Aviation could reduce emissions through a mixture of shifting shorthand trips from air to soil, retiring older aircrafts, retrofitting existing fleets with energy efficient features. Reducing emissions in marine shipping could involve slower growth in tanker demand as well as usage of decreases. Improvements in fuel efficiency and the use of alternate fuels, for example, green hydrogen based, and forestry also. Forestry, other than land use, accounts nearly 14% of annual carbon dioxide emissions. Forestry contributes to emissions through carbon dioxide release into the atmosphere from land cover change and the release of carbon stored in soil from land cover change. Forests play a crucial role in decarbonization as natural carbon sinks, absorbing carbon dioxide and releasing oxygen to contribute to negative emissions. Next. This is a very interesting slide. Carbon dioxide is generated by the industry. But what happens when I buy a textile, suppose a jacket which is produced in China? I am using it in India. It is produced in China. But China's factories are running for me. So China is producing that carbon dioxide, whereas I am the ultimate damager. So that is why this chart shows how the trade flows balances the carbon dioxide generation from country to country. You can see the broadest one is from China to United States. United States is a very consuming economy, a maximum of $30 trillion, very strong economy. And China is the manufacturer till the COVID. But now things are changing. This is an old chart. Things are changing. You will find that India's curve is also getting thicker and wider. Maybe other countries and China's are getting smaller. Next. Here it shows that how the carbon dioxide generation has been increasing over the years. You can see at towards the end there is a dip. The dip is due to the COVID effect, the COVID-19. Next. I've been told to wrap up, so I'm just going. So similarly, this is a chart showing that how the methane and nitrous oxide also is going up, the generation, and how they are damaging the total Earth atmosphere. In this, the top 10 emitters accounts for around 62% of global carbon dioxide emissions. So China is the maximum damager now. 26% of carbon dioxide emissions is generated by China. United States is at 12. We are at 6. We may go up in a short term, definitely, because our energy appetite is much more than China. We have to grow faster. Next is about the methane. Here also China is the maximum. 15% of generation is by the Chinese government, Chinese industry and power generation. So carbon capture, utilization and storage often refers to an engineered removal of carbon dioxide, commonly via amine scrubbing, a chemical process that absorbs carbon dioxide from exhaust gases. It can be used to create negative emissions, either by level required to achieve 1.5 degree Celsius goals range from 5,000 upward to 10,000 metric tons per annum power, alternate energy to drive of power plant, green hydrogen fuel for mobility, and so on. Entire scientific community are at it and working day and night to resolve this problem. One individual and collective scientific research is required to bring this generational change. So with this, I come to the end of my speech. So this is the net zero transition. The challenge is very, very huge, where everybody, every government, every individual, every industry, every research scholars have to work on this to say that how fast we can get to that. Otherwise, this globe will be warmer and warmer and warmer. Thank you very much.
Thank you so much, sir, for sharing your knowledge with all of us. Now I would like to request Dr. SVAR Shastri, sir, to please offer a memento to our honored guest. Now I would like to call upon Sri Mahendra Pingal, sir, who is GM of Tata BlueScope Steel, and his topic for today is Composite and Smart Materials Building Construction. Sri Mahendra Pingal, sir, is a dynamic leader currently serving as the head of tech marketing at Tata BlueScope Steel in Pune, Maharashtra. That brings a wealth of experience from previous roles at BlueScope Steel. With a Master of Science in Chemistry from the University of Pune, he possesses a solid foundation of knowledge and skills in the steel industry. Transitioning into his current role as General Manager for Marketing and New Product Development at Tata BlueScope Steel, Sri Mahendra sir leverages his extensive background within the organization, having held various positions across Tata BlueScope Steel and BlueScope Steel. His expertise encompass steel, product development, key account management, marketing, and management. May I request Sri Mahendra Pingal, sir, to please come over the dais.
Good afternoon. I'm not going to take a lot of time because already the program is getting late. In my presentation, I'm going to talk about the smart materials.
as you know, seen it, green and sustainable, what are the impacts nowadays we are facing because of carbon emissions and all these things. So what are the smart materials going to give the benefits of reducing the carbon emissions? And that is what I am going to talk about this. Just to give a brief about Tata BlueScope Steel. Tata Steel, and BlueScope Steel Australia, they're also making steel from iron ore. So this is the two companies come together, forms joint venture, and it is started in 2005 onwards. Before that, the color bond steel, which is the leader in coated steel technology, it has been imported from Australia and it has been serving to Indian industries. Over 25 years, color bond steel is performing well into the building and construction industry. There are a lot of the stadiums, there are metros, airports, buildings being made out of color bond steel. So we have the plants, 3 plants located in the Tata Steel. We have the plant in Jamshedpur, we have the plant in Khopoli, and we have plant in Meramandali. So our total 6 million capacity, 0.6 million capacity for making the coated steel products. And this is the product which we are offering for building and construction industry. So these are the coils made out of the zinc aluminum coated steel and color coated steel. These coils are further processed and make into a profile sheets. And we have the plants around India to convert the coils into profile sheets, and we are selling under the name of Lazat. These are the roofing and wall cladding profiles. We'll go into detail about that. So these are the brands we are offering in India. Zinc aluminum steel is the product which is zinc aluminum alloy coated steel coils. The color bond is pre-painted zinc aluminum steel coils. We have the Lazat, that is the roll form products. We have the Durashine, which is the retail product which is available in retail shops. And we have Easy Build, which is light gauge framing system, which is a complete building which we are offering to the Indian market. So our product is green and sustainable. That is what been certified by the IGBC, GRIHA certified, and our product is EPD certified. We have declared what are the carbon emissions produced while making steel, and which is going to help the designer and the architect consultant. They can refer what are the carbon emissions produced while making the 1 ton of steel. They will compare with the other material of the competitions, and they compare and they will select the product. So this is going to be a good things for the Indian industry, which is going to help to reduce the carbon emissions to the buildings. So these are the sectors we are serving. All the sectors, our presence is there, and product is performing well over here. So I will play one small video about the company. Please bear with me.
All day, every day. The sun is coming out, a new day is on its way. We promise to keep you covered all day, every day. All day, every day, we've got you covered. All day, every day. So is sleeping in peace, or resting in the shade, making memories for life.
industrial, infrastructure, manufacturing and warehousing applications to small and mid-sized projects like homes, schools and offices. Tata Blue Scope Steel has been touching many different lives all day, every day.
So you have seen what we are doing. So nowadays construction technology shift is happening. So from conventional building to a smart building, the ordinary RCC building to steel buildings, whether it is a ground floor or multi-story buildings. What forms a kit and send it to the sites, and it is just assembled. Where you can see we can reduce a lot of green emissions. It is no electricity is required, no any power is required, no cutting and welding is required at site. The site is very clean, no VOC or nothing is there. So this is one of the example of the latest technology where we have supplied about 122 buildings, which is fabricated in the factory and supplied to 38 locations in the 4th state. You can imagine this line, the pipeline goes to the forest. And you can imagine whether this building can be made out of it. And that way, building is required zero maintenance because no one is going to go and maintain the building. So such type of buildings, which is a weatherproof buildings, leak-proof buildings, which is being supplied in the forest and erected in the forest without any electricity. So that is the technology we can talk. This is giving the boost to the infrastructure projects where we can meet the speed of infrastructure and where definitely we are going to increase the steel consumption per capita. So that is what we can talk about the green and sustainable buildings which can meet and speed up the things. Some problem is there in the screen. So you can see the buildings. Can you see? Yeah. What happened? Yeah. Okay. So buildings used to be built or fabricated or architecturally designed with of simple portals. Now architects and designers are working, making the buildings or designing the buildings with the beautiful shapes, structures, which can give us the beauty to the structures and so on. So there is some technology glitch here. Please bear. Not visible. Yes. Yeah. So two portals can be designed with the simple structure, and the building is look like this. So this is the technology advantage. Also the beautiful buildings you can see, and this is what the architects delight, where we can whatever he imagine the shape of the structure, the reality is possible using the smart steel on this. So you have seen a lot of roofing material is being used since decades. Nowadays the preference is going to be at metal coated steel, which is giving a durability, longevity, green and sustainable material, and also thermally efficient buildings. Roof can be designed with using our material. We can talk about in detail about that. So nowadays the modernization is happening. Old railway stations is going to rebuild, remodernized, and they are also looking for green and sustainable material which can give a long lasting performance as well as the long term aesthetics. And the option is that the color coated steel material is there which can add the value to the beauty as well as the durability of the structure. So nowadays you can see, you have seen that the RCC tank is getting replaced or used with the water tanks. and the construction time is reduced almost one third, and that is what in UP government has been promoting this, or they are demanding the early purchases of the water tanks, and this latest technology has been used for making water tanks, and our product is being preferred material because it is giving a longevity, aesthetics as well as the durability for this. So the color bond steel is made out of zinc aluminum coated steel, is pre-painted steel. The technology has been developed by Blue Scope Steel. The BIIC is now Blue Scope Steel. So they have improved the performance of the galvanized steels to a zinc aluminum steel, that is named, where 55% of aluminum and 43.5% of zinc and 1.6% of silicon is being added into the metal pot, and which gives long-term durability. Means the galvanized steel of 275 GSM, which is giving a shorter life, with the zinc aluminum steel with this composition gives up to 4 times long-term durability. So corrosion resistance of the color bond steel or zinc aluminum steel, it has been multifolds, we can say 4 times. So that is what the sustainability and durability comes, and which talk about the green and sustainable buildings, which gives the affordability and durability in that sentence. So zinc aluminum steel, this is the alloy, we can say, this is the combination of that. We offer AZ200 GSM, maximum of it, and that is going to be preferred for the project market where the corrosion resistance is required very high. So if you see the salt spray test, the zinc aluminum steel is going to give higher protections than galvanized steel, and this is the laboratory test. But if you see the actual performance over 20 years, the zinc aluminum steel is still performing far superior than galvanized steel. So you can see the aesthetics of zinc aluminum steel. It is, the luster keeps longer, and you can see that you don't need to do any replacement in early days. So if you see the coating comparative life in various environmental conditions, so on average we can say up to 4 times, but if you talk about industrial or a corrosive environment, the performance is more than 10 times. So performance in respect to the environment is going to be predicted here. So color bond steel, this is another material, smart material we can say. It is a color coated zinc aluminum steel, which is history in India is more than 25 years. We have recently completed 25 years of presence into India. So this technology originated from Blue Scope Steel. It is a patented paint technology. I believe you people are knowing because of the paint, and you are the masters into this. So we have been associated, Blue Scope Steel is associated with the paint companies, and they are certifying the product's performance by referring the results at actual sites, the outdoor exposure sites. After that, they give the clearance of what are the resins, what are the pigments used, and based on that they develop the product. It is worldwide, 10 locations, and they are the leader into the coated steel technology. The product is tested and proven in aggressive environment, and we are for the high strength steel material where we can further reduce the steel consumption by 20%. So if you see the cross section in the paint system, because you might be referring to this, because I'm just going to detail about this few slides. If you take the cross sections of the pre-painted steel, the main importance is the resin and pigments and additives, which drives the performance of the product. The performance of the product is definitely this polymer. Definitely it will have a problem when it is exposed to the UV light. It's break down the bondings, and then further the chalking and fading happens. And we have to choose the right kind of pigments and right kind of polymer chain or polymer components, monomers or polymers, to selecting the right, which can use the strength to UV lights. So there are different types of resins which are used in the market. the RMP, which is a regular modified polyester, then silicon modified polyester, then there are super durable polyester, then we're talking about ultra durable polyesters. So name is generic names, but there is a lot of technology goes behind by selecting the monomers for making the paint. So the polyester, whatever we use, the polyester which is the cycloaliphatic structure and which gives long durability for that. There is another polymer which is polyvinyl difluoride, which gives color retention because the carbon fluorine bond is there, which is very strong bond, which doesn't impact on the UV light. So the color performance goes on long durations. So if you see, only take the polyester, and you can check the performance over a period of time with the various combination of polyester. You can see some product is going to give the color difference of delta E is 7.4. Of the same some polyester family with giving a 20.7 delta E, which is a color difference, which measured through spectrophotometer. So you can see how the technology goes behind. That is what you people are there to innovate the product, how the product is going to give long-lasting performance. Typically on the aesthetics. Aesthetics, which is color-coated, why we are using the color-coated steel? Because of the aesthetics only. And if you are developing the product which doesn't give a fading on a short period of time, or it gives a long duration aesthetics, definitely that product is going to be there. So you don't need to repaint it again. Once in the building and construction industry, once the roof is installed, you don't need to go and repaint again and again. So you have to choose the right kind of paint systems while selecting the product. So same thing happens with the selection of the pigments. There are different types of pigments, which are the inorganic pigments, which is naturally occurring pigments. There are ceramic pigments, which are very, very, resistant because metal oxides, these are the metal oxides. Metal is heated to a 1200 degree, then the oxides forms and then the pigments are being used. And very simple thing is organic pigments. It is very, very, quick, it is available, and the color fastness is very high. So they fade fast, but ceramic pigments and the inorganic pigment doesn't have that impact. It remains as it is. It will not change its color. That's why selecting the pigments, which is also very important things while making the paint system. So same thing performance, the organic pigments get fading and the inorganic ceramic pigments are very good for that. So Blue Scope still do that all R&Ds. The sites, test sites are kept at very close to the coastal and very industrial and high UVs. So we monitor the performance. Once the product is performing well over there for at least 3 to 6 years, then we take this into formulations. So the high UV regions, we also monitor the color performance over there. And we also go into checking the performance at the lab also. So, but lab results are very, very short. It is only to compare results with the competition or any alternative material. But which is not giving the real fact. So what is important, we have to go and analyze the sample, which is really exposed to the sites, coastal belts or industrial, and monitor the performance. If we do that, you can see the performance. The lab test results are very, very, it doesn't give that much impact, but the big sample which is exposed to the outside with outdoor sites, it gives wide difference. And that is what you can see the color bond steel, which is having the better performance, right kind of resins, right kind of pigments, additives, doesn't have that much impact when it is exposed to the weather. So another property, we can talk about the thermatic technology, because the paint is going to reflect more heat back to the atmosphere. And the heat reflect back to the atmosphere, which is infrared light, which is normally gives the heat to us. So whatever the paint system developed by Blue Scope steel, which is giving a more reflectance value, so that heat radiated inside the building is going to be less. So we have selected the pigment in such a way that it will reflect more heat outside and not penetrate the heat inside. So that is what you can see the technology which is a green and sustainable with a high energy efficiency paint system which we have developed in our things. So you can see that you don't need to add additional insulations, you don't need to replace the sheet because it will have less thermal expansion contraction, and the color of the building is going to be remains for a long time. So these are the benefits of Thermatec technology which gives less energy consumption, which we can save a lot of cost over there. So what is the solar solar reflective index? Higher the reflectance, more the roof inside is cooler. So we have the paint which reflect 90 to 94% of the reflectance value, and nowadays this has been preferred in industrial, making the industrial buildings where we can save a lot of steel. So this is one of the case which we have done with the Green Star, which is lead in US, using color bond woodland gray color. So you can see the total emission is 37 tons per 1000 square meter of the carbon emission is reduced by using Thermatec technology, and the sheet temperature is going to reduce by 12 degree. So if you expose two sheets, color bond steel and the ordinary sheets into the heat, and you can measure the temperature. So there is a sheet our sheet is going to be less temperature by 12 degree, and you can compare the energy consumption is going to be less by 2.6 watt per meter square. So this is the technology, this is the innovations, and this is called smart steel for the building and construction, which gives the energy efficiency, it gives the beauty for your structure for building for long time, and it is recyclable, it is reusable, it is no VOC content in the product because it is factory painted, so on. So this is going to give a lot of relief for reduction in the carbon emissions. So we have a range of products. Some products are suitable for general environmental conditions. Some products are specifically designed for the coastal environment, and we have some aesthetic product which is metal. So we have recently developed the product which is for the aggressive environment, because we know that there is a environment which is impacting from outside, from nature, but there are the industries which are creating a lot of fumes inside, a lot of humidity inside while making the product. So the product should be withstanding from the bottom side also. So we have developed the product which gives the performance for the product, which you don't need to replace the sheet year on year. So this product is going to give the relief for the replacement, which gives the sustainability, which you reduce the cost of maintenance on this. And this product can be used for your animal husbandry, can use for dairy, can use for fertilizers, can use for petrochemicals, where the lot of chemicals generated while or fumes are coming out while manufacturing. That is what this is, a lot of protection from inside as well as a lot of protection from outside. So we also manufacture the product which is designer patterns, which is good for MES and all our interiors also, the wood finish and all those things. So it's a direct replacement where you don't need to cut the woods, and you can see the steel with the aesthetics of that. So nowadays the technologies are moving from factory reform product to on-site reform to meet the speed of the construction industry. And with the big structures where metro stations, airports, we take the machines to the site and roll from the sheets as per the the end to end. Sometimes the sheet required 100 meters, sometimes sheets require 200 meters. The single sheet can be roll formed at the site and directly installed on the roof, where you can save a lot of steel, because when you supply the product from factory, where you have to overlap it, the overlapping requires a lot of steel goes there. So if you go with the on-site roll forming, there is almost 8 to 10% of steel saving, and that is what technology we talk about. So different shapes of profiles are used, and so it depends on the site locations or architect likes. We have bold ribs, we have narrow ribs, short ribs, shallow ribs, which if you want to use for interior, you don't need to go with the big bold ribs. You can go with the shallow ribs, which gives the long aesthetics, add the aesthetic values. So there are simple machines, specially developed machines. It is a clip lock fixed with a clip. We don't need to puncturing the sheet. You can see the structures. There is a standing seam profiles which you can see to 360 degree. You can see the Trichy airport has been built by us with the different colors which gives a temple look. And this is a weather tight which is going to long-term durability. The Kanpur airport is also built by us, the roofing sheets supplied by us. So the steel is flexible. You can see whenever there is a requirement of the very nose, full nose type of structures, the sheet is there without any problems. So flexibility, durability, aesthetics, it has been maintained with the advanced steel. So along with that roofing sheets, these are the important the accessories required, which can use natural resources, where the skylights can be used, where you can do natural lights, so you don't need to use electricity. Insulation, you control the thermal performance. Rainwater goods, you can replace the plastics with the steel, which gives the long-term durability. We have the infill strips where weather tightness can be achieved. And we have the ventilator systems, which only ventilate the natural airs. No need to, it's not allowing the dust or sand inside the buildings. So that gives the protections. So if you want to make a building which is green, sustainable and durable, so you can go with the different combinations. How much U value, how much STC values, it can be designed. And that is what we are there to give a complete solutions to the building and construction industry. So natural resources we can use as a solar power generation, and these are the things which our roofs are compatible with mounting the solar structures, panels on the roof. And there are two different latest technology is the bipolar, where you can get the heat generation from inside as well as outside. So this high reflective color bond steel can be used for that, which generate heat, whether it is fixed or placed on the roof. So these are the smart materials. We talk about zinc aluminum steel and color bond steel. So with this zinc aluminum steel and color bond steel, we have the light gauge framing system. We can build a factory shed using cold form sections with the galvanized sections with 275 GSM, with the C sections, jet sections, and with the roofing sheets and nut bolt. So you can build the shade, which is light gauge. Very quick, within a month's time, your building is ready. But that building is not going to take the crane loads. But warehousing, small scales, this is the best product for this. We have smart truss. The zinc aluminum steel is going to be roll formed, and we can make the truss which is used for the roof. You don't need to use timbers and all these things. So this is a direct benefit to you. There is no termite and all these things. So smart built is a structure which is same zinc aluminum steel members, high tensile, corrosion resistant, and you can make a frame and you can make a truss out of it. And you can see the building, the canteen buildings, and this is in our factory, and we have been supplying that. This type of structures can be built on the old buildings of RCC, which can place additional floor on top of it. And IIT Madras, Chennai, they have the hostel buildings. All the hostel buildings, one floor we have built with the smart build, and the students' hostels has been built over there. And it is giving us exactly same look as what is building. You can't, from the distance, you can't differentiate whether it is extension of the building. So that sort of technologies are there, which helping the quick building the quick structures. So you can build ground plus one with the light structures. So here you are saving a lot of concrete. Here you are saving a lot of no waters required, and that is what the green and sustainable building is a future for this light gauge framing for the industry. So you can see these are the different school buildings, the canteen buildings. This is the rooftop extension. These are the applications we do. And talking about the green and sustainable natures, you can see these buildings are built in Australia with the beauty, with the corrosion resistance, and it is merging with the environment, not damaging the environment. Because whatever the paint system we use, it doesn't have heavy metals. It's a lead free and cadmium and all these things. It is not there. So we care of the environment, and that is what it is. The product is certified as green nature. So whatever the inspiring, whatever the architect desired, this steel can be built of this. Different structures, curvatures. You can see the buildings, which is beautifully designed buildings, and this is possible in steel. No need to go for RCC and all these things. You can see the beautiful structures built in other countries. On the sea. This is a product which is corrosion resistance, gives a durability, aesthetics as well. Stadiums, big spans, and beauty remains there for a long time. This is a Pune metro. You can see the high tensile steel, no screws visible out from outside, fixed with the clips, and the complete metro is been built by us. We can put the solar on top of it, which generate the electricity, and that is what these structures, stations are going to be getting the green certifications as platinums. This is Agra Metro, which we have supplied. So we are doing the prestigious project, and which is giving long durability and aesthetics. Yeah. So you can see, you are also seeing that whenever you going in the industrial belt or in metros, the buildings architects are designed the good steps, but the contractors playing with that. So if you select wrong material in the beginning, so over a period of time the blue colors change to white. So that is the problem. Because people are ignoring the fact all color-coded steels look like same, but there are technology, there are selection of right kind of paint system is must, and you can see this type of wiki if you are not selecting the product in right way. So we are educating the markets and professionals, go for right kind of products in the beginning so that they will avoid all such type of problems in near future. Selecting the right paint color. Bright colors are not good because the bright colors are only possible with using organic pigments. We have to go with the inorganic pigments, which is earthy colors, dull colors, which are going to give more durability than the bright colors. So that is what is a 3M building. The corner is original color. Over a period of 3 years, 4 years span, the color changes to this, totally gone. It's totally different colors. So if our building orientation is also important, and the colors should be also withstanding to that. In the wall which is facing towards north doesn't have the fading. You can see less fading, you can say, but the wall facing towards the east with the sun, the wall bands are gone. So that is what the product is available in the market. The option is that's why the color bond steel is being preferred, because by the architect, because they are very comfortable ones using this material for their projects. And that is what within a 10 years, 12 years of span, our buildings in the coastal region doesn't have any fading. And that is what we talk about, the genuine aesthetics and long-term performance product. So another part, we are also doing the composites. So we have structural decking, which is also saving the concrete saving by about 20%, steel saving by 20%. So nowadays this is also important fact which we are getting used in the multi-story building, which is the composite structural decking. We design the structure, we help on designing the structures, and which is giving that. And these are the buildings is built by Blue Scope in other, and this buildings still there, and it has been the landmark buildings in that country. So talking about the green and sustainable, steel is the preferred material for that, and because it's 100% recyclable, energy efficient, which we talk about high solar reflective index product, which has water conservations and environmental impact which is low because we don't use heavy metals, and design optimization, which is important things nowadays, where we can save 24% of the steel consumption going to the high tensile steel over the softer grade steel. And that's it from my side. Thanks. Any questions? If it is there, we can have that, or we can take it on. thank you, HBTU for giving opportunity, and on behalf of WNs, we thank you for this. Thank you.
Thank you so much, sir. Now I would like to request Dr. S.V.R. Shastri, sir, to please offer a memento to our guest. Now we move forward towards the panel discussion. The topic for the panel discussion is expectations of industry from academia. The moderator is respected Shri Vishwanath Chattopadhyay sir, and the experts are Shri Anup Trivedi sir, MD, Tata Blue Scope Steel, Dr. Ritesh Mittal sir, GM, Engineers India Limited, and Dr. Raghuraj Pandyan sir of NIT Warangal. I would like to request them to please come up on the dais.
Yeah, we are already late, but we will start the session, but we will not take much time, maybe 20 minutes. We have three panelists. I would like them to first introduce, although I know Mr. Trivedi. Can you see that? Why it's not?
Yeah, hi, good afternoon. This is Anup Trivedi. In the morning, I was introduced, and I have some 28 years of work experience, mostly in Tatas. I am a metallurgist, mostly dealt with steel. I'll try and do justice to the topic which is shared with us today. Yeah.
Good afternoon, everybody. I am Dr. Ritesh Mittal from Engineers India Limited, and I am a chemical engineer by profession, working in the field of biofuels from last 2 decades, and I'll be sharing my views on the given topic. Thank you.
Hello. Yeah. I'm Professor Raghuraj Pandyan Kupuswamy, and I'm representing academia. Currently doing a faculty from Department of Chemical Engineering, NIT Warangal.
The topic of today's panel discussion is expectation of industry from academia or expectation of academia from the industry. I'm changing it again because you need to complement each other, then only we can have a success here. So I would request the panelists to speak 3 minutes in this subject. What is their view so that we can take the discussion forward.
Yeah, thanks once again for inviting us and giving us this opportunity. So the topic, and very well, beautifully it is now re-articulated that expectations from should be from both the sides. But let me start where I would know better, which is expectation of the industry from the academia. So the expectation is when we are what is the primary purpose of any industry? The primary purpose of any industry, if you have seen when Nano was designed by, and Mr. Ratan Tata had conceived it long time back, when he saw a family on a scooter and it was raining, and he said that why should we have a car or some piece of equipment which can transfer a person from point A to point B, and that is how the Nano was born. So every industrialist has a purpose. So for example, in the morning I was saying that Tata BlueScope, we have a purpose of providing shelter to everybody. So once I have shelter as a purpose, then, and that's obviously with that purpose I will want to generate money, and as good corporate citizen, lot of it I plow back into the society. So Tatas would make cancer institutes and name any CSR activity, and we want to be there. And how do we do? So as one of our companies, if I make 100 rupees, 60 rupees I plow back into the society, and remaining we spend on the growth and on the employee. When I am having this aspiration of shelter to be provided, for example, किसी एक गांव में एक विलेजर को एक बफेलो शेड बनाना है और उसको एक शेल्टर चाहिए, तो आप एकेडमिया से मेरा रिक्वेस्ट ये है कि हमको वो ऐसा प्रोडक्ट बताए जो कि बनाना भी आसान हो, फैक्ट्री के अंदर लगाना भी आसान हो, और वो सुंदर भी दिखे और ज़्यादा टाइम तक चले, क्योंकि if that villager is spending 1 lakh rupee to buy some 20-30 sheets for a cow shed, he can't spend 1 lakh rupee every second day. 1 लाख रुपए उसके लिए बहुत बड़ी बात होती है. तो कैसे आप लोग हमको मदद कर सकते हो एक अच्छा प्रोडक्ट बनाने में, विच इज ए कॉम्बिनेशन इन दिस केस ऑफ स्टील एंड पेंट, और उसको लगाना भी उतना ही आसान हो. उसको लगाने के लिए फैब्रिकेटर उसको बहुत डिफिकल्ट नहीं हो लगाना, वो खुद जाके लगा सके. क्लिप होना चाहिए जैसे महेंद्र पिंगले दिखा रहे थे, बोल्टिंग नहीं होनी चाहिए. और तीसरा है कि उसके 1 लाख रुपए की कीमत उसको अगले 15 साल तक मिलनी चाहिए. So this is where we want help of academia in the sense that we want to partner with academia also, to an extent that we would like to go with you to the markets and identify the needs of the user. Today, why is it so that everything which we do here, other than software, the product or the design is first made somewhere else and then we will copy? That's not fair, right? This generation wants to design and produce here itself, and that should be our aspiration, and that can happen only once. So all the steels also today which I am talking about, all the steel which I am talking about was developed somewhere else and we are just copying. We have to stop this, and that can be stopped only when academia and in the industrialists we come together, go to the market, understand the need and the purpose, and design the product accordingly, so that it is easy to use and has longevity and aesthetics. So that is the expectation. Thank you.
Good afternoon, everybody. So expectations from academia in itself, I don't think that's the right thing, because we should not expect anything from academics. Academics is a place where the education nurtures. And as I can remember now, in the last 20 years, there has been corporatization of education. We all are busy publishing papers and patents and everything. The only thing is, when the student passes out from the college or a university and enters the industry, industry is an ocean. In whatever exotic field or normal process industry or wherever you lands up, within 6 months or a year, industry teaches that boy or a girl how to be, how to maneuver inside the industry. So the expectations, only thing is that we should always make that student industry friendly so that he is very adaptable to the industry. So as the new frontiers opens up in the industry, that the innovation is happening every moment. There are different challenges for the industry. The student should be aware of them. Even if he is aware, then he will be easily able to maneuver that. So all the professors and the students, they should work upon it. The first thing is about we teaches different softwares in the university. But in industry, these softwares have a very practical application. We are taught only the sketchy part of the software. So the curriculum should have specific subjects oriented to oil and gas, pharmaceuticals, fertilizers, those software, and even safety softwares which is coming up. You have life cycle analysis software. So our students should be given exposures to these software. That is very important. And second thing is, instead of doing exotic research and publishing papers, that is essential for any university and the professor. But basic troubleshooting, basic things with the industry exposure should be given, due importance. That will help the faculty also and the teacher also. Otherwise, as such, you have an expectation from industry have expectation from academia that it has no end. But they should join hands and move together. That's the only thing. The crux of the thing is that you should make students able to maneuver in the industry very fast. And if the alumni is very good, then obviously the university or the professors will also get back from them. It's a 360-degree process that will return to that university. Thank you.
Yeah. So as a faculty, nowadays, we are not supposed to do teaching. So for an example, in my case, I can take one example. There was one BTech student from Pune, so who studied in NIT Warangal. So after his completion of degree, so he joined this fund and he provided us 6 lakh rupee for small project, 6-month project to their juniors. With that project, he applied to Government of India for startup grant and he got 1.5 crore rupee project. So here comes the crux, technology readiness level. So every project, every funding agency, these days we have a criteria called technology readiness level. So if I want to submit a proposal for funding agency or to an industry, I have to convince them that this is possible. So my idea is commercializable. So how it can be done? We should have preliminary results. So that is what these days are very, very important. So we work out for 1 to 2 years on the primary level and we develop the prototype and we convince the industry that this is possible. And another important thing, these days I request all the industries that you doesn't need to provide any economical support. So whereas you support us to from the developed level, that is from the laboratory level, you try to develop the product at the full scale. And you take the onus on commercializing the product. So as an academician, I'll be there till like lab level production, then the scaled up product, till level we will be there. But as an industry, you will be the expert how to commercialize the product. So that's all from my end. Thank you.
I think all have spoken about how the synergy has to be established between the academia and the industry so that we get some, what is happening in the Western world is a perfect synergy is there. Their educational system is different than ours. We are too academic without having a practical approach. I am also from the industry, so I can suggest that every industry has a CSR fund. So maybe a certain amount of CSR fund is assigned for the for the development of new whatever product or this thing, in association with the academic institutions, and encourage them so that they come out with some kind of new development. Although I have discussed it in our board, but I'm just throwing it out so that the CSR is there for a good cause. You are doing it for the society. But for research also, if we can give certain amount of fund for the for the research areas, then also we can see some results. The problem with the industry is the industry per se, the owners have a trust with the academia of Indian academia. Honestly speaking, if it is coming from US or Europe or UK, then we feel that yeah, they must have done some research, so if this product has a value. But for India, we don't have that. But we have to build that trust in the process of working together. But for the working together, we need money. The fund has to be sourced from the industry, of course. The government is helping the academia. I'm not saying the government is not helping, but I think the CSR fund will be one kind of process where things will be improved. Raghuji, I want to ask one thing, that recently the new education policy has been rolled out, and in that we are seeing that 4 years was has been there in United States and Europe, so 4 years for the BSc also, 4 years for the engineering also. Do you think that in this new education policy you will get something for the industry?
Yeah, definitely. So what I have seen from the new education policy is that the curriculum is totally to fit industrial needs. First of all, from these days, from first year onwards, there is a subject called design thinking. So till final year, that is getting continued. From NIT Warangal, only BTech students develop certain patterns. So simpler problems. They had been rigorously presenting the things every week, every month, and they improved the design, and they have several design patterns. So this is best example what you can see that it comes from the new education policy because of the curriculum revision, and you are making the students to think and you are making them ready-made material, not even for the industry, for all societal needs. Thank you.
Mr. Trivedi, how to increase the entrepreneurial skills in students? That's a very important thing because startups are everywhere. So how that has to be, incubated in the minds of students from the very early stage?
Yeah, actually, I don't know, there's some telepathy. I was actually thinking that we are not touching upon this subject, and it's so very important that there is a batch of some 50 people in a class, and then obviously there will be some passion, and some wants to become professors, and some would like to go to industry, some would actually become an entrepreneur and they want to start their own business. But how does this change happen, and who goes where? So to a large extent in India, it also depends on where do I get a job, because getting a job itself, I don't know the current markets, but during my times it was a very difficult situation to get a job. So some would depend on what job did I get in the first instance, and that is where the college helps. College helps me only get the first job. After that, college or my rank or my scores, I have found not to be so relevant. It is all about my merit, my persuasion, my skills which you mentioned, my entrepreneur skills. So it depends on how do I navigate. But if we are coming up with a new curriculum, are we considering those aspects where if I have read an engineering subject, out of that I will use only 2 to 5% in the profession which I am in? I mean, use nothing. If a civil engineer joins a software industry, I don't know how much will he use. A ceramics engineer joining a software industry, I don't know how much will he use. But let's say if I go to a relevant industry, there also I will use only 5%. So then what is that 95% which makes me click into becoming a satisfied person, even if you don't want to tag it with a designation, let's say managing director or a CEO or whatever. But how do I become successful? And I think that is what we are not even covering anywhere. And there is where the, this practicing people from the industry should be invited more often to the academia to talk to the students, to tell them that what actually clicks. And what actually clicks will not come from the success stories. It will only come from the failure stories. what are the things which I would have avoided in my life, because of which I just escaped a failure. And the second one, which actually our parents also taught, how much could I imbibe, that many of us started our career together, but how many times did I fail and I stood up better than somebody else? So these are two things which will help me. The second thing will also help me in my personal life. You know, the kind of the nuclear families which are getting created, and it is just impossible. If my family is in helter-skelter, my professional life would be too good. The family has to be good to make the professional life good. And to make that family good, am I able to have that emotional quotient and strength to stand up after a failure? And is this being taught in a school or a college? I don't think it is taught so much. We learn as we proceed in our career. We fall, we learn. Probably somebody is learning it better than somebody else. And if there were more books, and I would like to write a book after a superannuate only on my failures. How many times did I fail and how did I handle my failures? Probably learning from my failures with the audience would be better than success. Right? Success is easy to imbibe. Learning from failures would be better. The second thing which I want to tell you is that if you see in your schools and college days also, there are some students who navigate well in a very difficult situation. Believe me, only the context changes, people's name changes, the situations more or less remain same. The guy who was able to navigate beautifully in a college day, a very difficult situation, whether it was with a professor or within the students or with the society, the same person has that navigation skill when he goes to a college as a professor, or when he goes to an industry, or he starts a startup. So probably those are the skills people should also think about when they are thinking too much around what is that CGPA or CPI or percentage scores, because world over people have seen the mediocres have done better than anybody else. Probably those mediocres were able to navigate the situation better. So just to focus there. Yeah, IICHE is an example. So I would request that please focus on your studies, on your, so for example, I should focus on my job, but nobody told me how to deal with the board. No college or school told me how to deal with the board. So recently, 10 years back, when I started dealing with the board, I had to read a book called CEO Excellence and Inside Boardrooms. So then what is the curriculum? Are they not supposed to tell me how to deal with the board? Where I will have 5 superiors sitting in front of me and asking questions every 3 months. So think through that. I think people who navigate well in their life will navigate well in their professional life also. Yeah, that's my view.
Thank you. So, honestly speaking, here the IQ plays a very big role in any student's activities, you can say. I just came back from US. Have you anybody heard about an app called Rovers? They are coming to India also. But I just got to know about Rovers in US. So it is nothing. It is not about education. It is not about industry. It is about nothing. You know, in US, it's very in fashion that you have a pet at house, but you don't have the time to walk the pet. So there is an app which matches the pet owners and pet walkers. And the app was sold at $1 billion recently. Out of nothing, they created such a big, entrepreneur. I am really surprised. So basically, the students need to have IQ, and of course, the talents for the education, whatever is being taught in the classes by your teachers, you must learn that. Also, you need a supervisor. Now, sir, to Mr. Mittal about the corporatization, you use that word, corporatization of the education. I have a question. In the corporatization, who benefits, corporates or students?
See, that's what I was saying. The corporatization of education is basically detrimental. It neither helps industry nor the academicians, because the students are in their tender age, 16 to 21 or 18 to 22, whatever it is. So if you pressurize them with doing the projects. Students are not meant to do the project. They are not bonded laborers, first of all. So I'm not saying, I don't deny the fact that they should not work in the research, but they should have, like sir was telling that, failures, navigating, everything is important in life. But if you make them work inside the labs or the corporate, because corporate is always time bound, you have to deliver. There's no, you cannot say that I have published the paper, I cannot do this or that. If you are really working on the projects, what I have seen, the students are very pressurized. So this pressurized students, when he reaches the industry, he will not deliver because he's already exhausted, because life is a battery. If you discharge him in the earlier age of life, he won't be able to deliver in the future part of his life. So that corporate, and secondly, even the faculty, they are very pressurized to publish papers because the promotions are related to papers and everything. So this thing was not there 2 decades back. So it should be free. Research cannot be compulsive. Research is born out of mind. If somebody has a particular topic in which he can only publish a paper, and I am working in a field, I can publish 5 papers, they both are equivalent. You cannot judge on the basis of the papers. So the corporatization doesn't help anybody. This is just the materialistic. You are making education materialistic. Education is something the institutes, at least at the PG, undergraduate level, they needs to nurture themselves. That's what I was trying to say. So thank you so much.
Very well said, Mr. Mittal. So I think we have, due to the paucity of time, the discussion has been going on for ages. Industry or education or academia is going on, but it's complementary. It is 2 sides of the same coin. We have to be, bound together by that glue and see that the results automatically given, so that at least India as a country where the talents are there, but our products should also get established in the world. I have one story to tell you before I wrap up this discussion. How many have you seen the one statue called David? David is, they say that it is the perfect man naked statue. Yeah. And it's been done by the Michelangelo. So what happened 600 years back, the piece of rock was lying over there, and it was getting not rusted, it was just getting dusted. Actually, nobody was taking care. And the Italian government, it is in Florence, that David statue. The Italian government was trying to call all the artists, because at that time the Renaissance of Europe is going on. So many artists came and they saw the rock, that marble rock. They said, no, this is a useless piece of marble. I will not be able to work with that. Even Leonardo da Vinci also came. He also saw the rock, but he said that, no, I can't really carve anything out of that. Then 200 or 100 years later, Michelangelo came and he carved out the beautiful David statue out of it. He sculpted out. Now, the moral of the story is, Michelangelos are there, the professors and the industry experts. The rock is the students. So ultimately, the teachers or the professors have to sculpted the rock, the best statue out of the rocks which are there, and take out the David out of it. And the David is the best product in the market. Thank you. Thank you very much.
Thank you so much, sirs. Now I would like to request Dr. S.V.R. Shastri sir to please offer mementos to our panel experts and our panel moderators. Thank you so much, sirs. With this, we come to the end of the panel discussion session. Now it's time for the lunch. I request all of you to please get back here at 2:45, and we'll start with the next session as soon as possible. Thank you.
यहीं पे है तो चलिए मेरा एक बैग है उसको गाड़ी में रखना है कहाँ पे है गाड़ी या एक्चुअली अच्छा तो मैं हाँ आप आई बिल्डिंग का सामने आ गया
जल्दी
Sure, definitely. Because with your views, I get to know that you are more inclined towards startups.
मेरी अपनी बुक रखी हुई थी वो बुक
सब बुक रखी थी
क्या हुआ?
एक बुक थी
मैम सर की बुक कोई रखी थी यहाँ पे मिल नहीं रही सब वो तो नहीं वहाँ भी रखी है
So orange tag book?
हाँ जी हाँ जी
एक उठा दे दो orange tag book. कोई रुक रहा है मेरे साथ? ये लोग खा ले ईशा जो खा ले मैं खा लूंगी तुम देख ली वहां पे कोई रुकेगा मैं हूं एक मिनट नहीं आप फर्स्ट आप जा रहे हो तो मैं चल जाऊंगी हां
मैम आप जब जाएंगे तब खा लें
अरे मुझे टाइम लगेगा
हमारे भाई जब जाएंगे
ये भी तो रुके हुए हैं
आप तो बैठिए आराम से आप ज़्यादा करिए नहीं आपको नुकसान हो जाएगा
हमको टाइम है
कोई लाइफ तो उठा जरा
क्या ये लैब को वर्क हमको ज्यादा पड़ गया था क्या आवाज नहीं कर रही थी इसमें
अच्छा ये बताइए आज आप लोगों को क्या ये पहले डांस बाद में ऐसा तो मैंने कभी नहीं था
मुझे पता है
लाइफ में उठा दे
पॉज करो
हटा दे पॉज नहीं होती है
ठीक है
नहीं होती है
तो लाइव स्ट्रीम क्लोज ना करो
अगर देखा जाए तो हिंदू शास्त्र नहीं, ये हमारे भगवान का अपमान है। क्यों? पहले नृत्य नहीं होना चाहिए, अगर तो दिन की बात हो, पहले उनका जो गीत वगैरह है वो होना चाहिए। हम पहले पहले भगवान को पूजेंगे, उसके बाद हम जो उसके आगे की एक्टिविटीज़ है उसको पूरा करेंगे।
भाई ये स्विच ऑफ हो जाएगा, 15% बचा है।
लाइट हटा देना बोल तो